Hello friends, welcome back to another video. In this video, we are going to learn the usage of inline function in the language C++. So C++ has a additional powerful concept called inline functions. In this is generally used in classes. So what happens is that if you use a inline keyword along with a function, its code will be copied at the place of calling. So let me show it to you. Let's say in generally let's say I had my main function. I had my main function. So let's say I'm going to, let's say I want to print out the cube of a number. Let's say cube of 10, and then return 0. That's it. So for this cube, let's say I want to write a function. Let's say let me pass an parameter as n, and then the cube function, what it should do, it should calculate the cube of the given number and then return it. So this might be the basic code, let's say. Now what actually happens is that at compile time, a link from here to here would be generated. So what happens is that your compilation or the execution starts from the main, and then it comes to the it wants to see out the value of cube of 10. So it calls this function, and then this calculates the control jumps from here to here, and then this calculates the product of these three, and then it returns. So that is the value which you will be seeing. So what this now let's say if I am writing inline before this function, what happens is that this particular block of code would be replaced with the call over here. So what it does is that it makes a copy of this whole code, and then it puts it over here. So at the time of execution, there won't be any jumping of control from here to here. So in the series of execution, it starts from main, and then the compiler, as we have used inline, this particular thing would be copied over here. This copying would be done at the compilation time. So at execution, it comes to here. So the code would already be ready over here, so no need of jumping from here to here. So this will improve the performance of your functions. So that is the reason we use the inline function. So now let me show you the code in actual action. Let me start the code. Alright, let's start coding. So we want to see out the cube of 10. Now let me define the function cube. So as this is a simple code, I want to write only directly return. Let me build it. Alright, so now we need to put a breakpoint at this line to check the time taken for the execution. So what this breakpoint does is that it stops the execution at this point and it breaks the execution. Let me execute it and see. Let us see the results. See, it took 0.94 seconds to the completion. Let us write out how much time it took without inline. Without inline, it took 0.94 as you could see over here. That's why I have placed a breakpoint over here. It made the execution to stop, and then it gave us the time taken for the execution, 0.94 seconds, and no inline over here. I have written it over here. Let us write the with line now, with inline. Let me write the keyword inline, and let us do the execution, and let us see the results. I have built it, executed it. See, it has taken only 0.18 seconds for the complete execution. So 0.18 seconds. See, it took 0.94 seconds without inline, and then with inline it took only 0.18 seconds, which is approximately 8 times as faster. So this with inline keyboard has done our work very easily. Now let me explain the actual mechanism what had happened. Let's say I had no keyword inline. What would have happened is that after the compiler seeing this main, it saw this cout, after that it saw this queue, so that the control of execution has been jumped from this line to this particular line, and then it calculated this return, and then you got the answer. So all this jumping from here to here took a lot of time, so that's the reason you got 0.94 seconds for it. Now what happens if you put a word inline before it is that this particular block of code which is enclosed in this braces would be replaced over here with the function call. So you don't have any function calls now. The compiler would manage it and write directly 10 into 10 into 10. That's it. So see, for the compiler to execute this particular line of code without any jumping, it takes less time than compared to jumping from here to here, from here to here, and then executing this particular code and then jumping back. So these jumpings are called as function overheads. These function overheads are not there in case of inline function, so your execution would become much more faster, as you have seen. And there might be many cases where you are not allowed to use the inline. Let's say you have while statements, looping statements. In looping statements, in like, let's say if you have a for loop, or let's say any other loop, this loop code won't be copied and it won't be put over here. So irrespective of the keyword inline, the performance won't be changed. So if you have a for loop, this inline won't have any effect. And if you have a recursive call, like let's say if the queue function is again calling the queue function, let's say with another parameter, and this calls again this function, in such cases of recursive functions, we will not have any improvement in performance with inline functions. If the code is of only one line or less lines as I have shown. Now you could actually see the performance improvement. This particular code will be replaced over here, your performance will be increased. So never use inline if you have a loops or recursive, else you could use inline to improve your performance of the system drastically. That is the usage of inline function. That is it for this video. Thanks for watching this video. Bye bye.